Hello students, welcome to the lecture series of M.Sc. Part 1st Physics of the subject Mathematical Methods in Physics. Okay, this is a lecture number 4. In the last lectures, in the lecture number 3rd, that we had discussed about the complex functions and some elementary function of elementary complex functions. Okay, so today in this lecture we are going to discuss limit of the complex functions and the derivative of the complex functions. Okay, so let's start. First, that is limit of complex functions. Okay, so in the real case, when we study the limit of real functions, then we know the definitions of the real case when we study the real case. So limit is x tends to 0, f of x is equal to L. Okay, this is a definition for the in the real case. So here is two conditions, that is one, that is mod f of x minus L is less than delta, and another, that is x minus in the mode x minus x naughts is less than epsilons. Okay, so epsilons. Okay, so this is two conditions in the real case, and this is a definitions. This L is a real number, is numbers or the limit of these functions, and this delta and this epsilons, these are the two positive quantity. Okay, okay, so what happens when this x naughts, this is a point we consider in the real case. Okay, and this x, that is a neighborhood of in complex numbers we consider neighborhood, but here x naught, this is points, and when this x is approached closer and closer towards this x naughts, then the similar this quantity, that is f of x, is behave in the another planes like that. Okay, so this similarly, if I write for the complex functions. Okay, so let's I will explain this how it is changed in the complex functions. We discussed the two planes, that is the z planes and the w planes. Okay, so if I write the definitions, that is limit z tends to 0 or z naught f of z is equal to L. Okay, and this in the mode f of z minus L is less than delta, and z minus z naught is less than epsilons. Okay, so now if I draw for this case, if I draw the z minus z naught, this z naught is one point in the, suppose in the z planes. If I consider z planes, okay, here I have one circle, and the center of this circle, that is z naught. Okay, and this z, that is the neighborhood of this z naught. Okay, so when I approach from z to z naught, okay, like this, and or this, here is numbers of points. Okay, so you can consider any points. Okay, so directions to approach towards the z naught, that anything. Okay, so like this, or the like this also. So first I consider this, when z approach towards z naught, what happens, and the radius of this circle, that is epsilons, this is positives. Okay, you consider any value, this epsilons that depend on you what you are considering. Okay, this is a very small quantity, so difference between this z to z node, it is less than this epsilons. Okay, so similarly kind of things that happen in the another planes, that is the W planes. So this L, that is a point here I am considering, and this f of z, the functions. So when this f of z is approaching towards L, and this radius of the circle, that is delta. Okay, so when this z is approaching towards z, similarly kind of things in this W planes. Okay, so this is about the limit of the complex functions. Okay, so this is one thing, and another thing is what, suppose I have these circles. Okay, and suppose I have this circle, and here is a z node, this is a point. So whatever the neighborhood of this z node that approaching in the different directions. Okay, so here is a number of way or infinite way to approaching to the z node. Okay, so if this if I consider this is one approaching case and another this second, this is approaching case, if this two case is same, okay, so we can, this limit is exist. Okay, at the in the for the W planes. Okay, I am considering here z nodes. Okay, so that's why let's I will take the one example, then you can understand better. Okay, so main is what, approaching. Okay, main point is what, approach here, how to approach, and the numbers of way means if we take the numbers two different path to approaching, and if we apply the limits that is z minus z approach to z node, then if we get the same value for the different path, then we can say this limit is exist. Okay, so let's take one example, then you can understand. Limit z approach z node mod z mod square divided by real z square. Okay, so this is one examples. Now if we take the mod z mod square, that is equal to x square plus y square, right? And we know that this z is equal to what, x plus iota into y. So okay, that's why I am right here the x square plus y square, and the real z square. So if we take the z square is equal to, that is x square minus y square plus 2 iota into xy. Okay, so real is what, x square minus y square. So I can write real is z square is equal to x square minus y square. Okay, so now if I substitute this x square plus y square here, and the x square minus y square like this, so I rewrite this. So limit z approach z naught, and I'm directly substitute these things, that is x square plus y square divided by x square minus y square. Okay, so if we change this x, this z in the term of the x and y, also this z is also we can change, that is limit this we can write z approach to z naught, we can write like this z x approach mistake x naught and y approach to y naught. Okay, so because this z is what, x, z is what, x plus iota into y. Okay, so when this x z approach to z naught, we can write x approach to x naught and y approach to y naught. So now what in the previous we discussed, here is a number of way to approaching to the z naught. Okay, so here is a two variables, that is x and y. Okay, so we can approach in the different way, like if I draw this, this is x and y. So if we consider this y is equal to 0 or x is equal to 0, so suppose if we consider x is equal to 0, okay, here, and y is approaching to y naught, so y is approaching y naught. Okay, so this is for one case in this. Okay, for this z approaching to z naught, and another case is what, suppose this is the case first I am considering. If we take the y is equal to 0 and the x approaching to x naught. Okay, so if x is approaching x naught, so this is the second case. Okay, so you can observe this y can approach in y naught. So here is two ways it can be approached. Suppose this y naught I am considering 0, or this x naught, that is equal to 0, origin of this xy plane. Okay, so this is x naught or y naught here, x naught or y naught. Okay, so this is origin of this plane. So if this y approaching to y naught, so it can be approached by this positive y axis, and it can approach by this negative, okay, from this negative y axis. So here is a two way to approaching towards the y naught. Okay, and another for the second case, this is the second case. Okay. So here is also two way it can be approached by this positive real means x axis, and this negative real axis towards the 0. Okay, here I am considering x naught as a 0. Okay. So this z naught we can write, this z naught we can write is equal to x naught plus I into y naught, like this. Okay, and this x naught and y naught, that is equal to 0 I am considering. So you can write here directly z is approaching to 0 also. Okay, so this is the two case or the two way to approaching to the 0, and another ones, that is if I consider this x is the x naught and y is equal to y naught, then here is one relations, that is we know the for the lines, or it can approach in this way also. So x y is equal to m into x, or y naught, okay, y is equal to m into x. Okay, this is a third case, and this y and x maintain this relation by the m's, that is m is what, slope. Okay, so these are the three cases to approach to the 0, and that is equal to x naught and the y naught. We consider the origin of this xy plane. Okay, so if I can write this x square plus y square divided by x square minus y square. Now here is a three case or the three path, we can say this is a three path, path 1, path second, this is the second path, and this is a third path. Okay, so here what case, y approach y naught and x approach x naught. Okay, simultaneously. Okay, so these are the three case if we consider in this equations. So we can get the three result Okay, and if this 3 result is equal, then we can say this limit is exist for these functions. Okay, so case first, or the path, you can say path first, that is what we considering x is equal to 0. Okay, and y approach to y naught, so y naught is equal to what? 0. Okay. And limit, that is x y approach to y naught, and x is equal to 0. Okay, so no need to write here. For your understanding purpose, I write here x is equal to 0 and x square. If x is equal to 0, so this x is equal to 0, and this the denominators, that is also 0. So what we get? Y square divided by minus y square. So this is minus 1, right? So for the path 1, what we get a result, that is minus 1, and if for the second case, that is right here, limit x approach to x naught and the y is equal to 0. Okay, so that is if x if we consider this y is equal to 0, so what is that? X square minus x square divided by the x square. Okay, so the result is equal to 1. Okay. So you can, for this is for the path 2. Path 2. Okay, for this case. Okay. So we can observe these two results. Here if we are approaching by y to y naughts, then we get it is minus 1, and when we approaching from x to x naught, then it is equal to plus 1. So this result, when we are approaching with the different direction, so we get the different result. So we can say this limit does not exist for these functions. Okay, and also from these two results, if we compare, so we can say that this limit does not exist. Okay, and if we consider this third case, path third, that is limit x approach to x naught and the y approach to y naught. So if I put this y is equal to m into x into the equations, whatever equations, x square plus y square, right? So x square minus y square. So this is equal to I replace this y as a m into x. So I can write here x square plus m square x square divided by x square minus m square x square, and this is limit x tends to 0 and y tends to 0. So if we take the x square is a common, so what we get? Limit x tends to x naught and y tends to y naught, x square by x square into 1 plus m square and 1 minus m square. Okay. So this is our result for the path third. Okay, so we can say this path is this path of depend on this m. Okay, in this case, okay, m is what? Slope of this line. Okay, so now you understand when we approaching the different directions, if limit is different, result is different for the different approaching, if we approach in the different directions, so we get the if we get the different result, so it is for the limit, we can say that limit is does not exist. Okay, and okay, if limit is same result is same, then we can say this limit is exist, okay, for these functions. So I hope you got this point, that is the limit of complex functions. Now next topic, that is derivative of the complex functions. And so this derivative of complex function is very important, okay, because when we study the analytical functions, so for this is very important. Okay. So derivative of complex function. When we study the partial differential equations, we know the definition for the partial differential equation, that is limit del x tends to 0. We can write f of del x del f by del x is equal to limits del x tends to 0 f x plus del x dash y minus f is x and y divided by del x. Okay, this is the definitions for the partial in the partial differential equations we studied. Okay, so this f is a function of x and y. This x and y is a two variables. Okay, so here a small change in this x, okay, that is a del x, and apply the limit, that is del x tends to 0. So this del f by del x, this is, we can write it is f prime of f prime x, like that. Okay, so similarly we can write the definitions for the derivative of the complex functions. So let's write. Okay, so if I write like this, f prime z, okay, is equal to limit del z tends to 0 f z plus del z minus f is a function of z divided by del z. Now this is a real quantity. Okay, f is a function, so this is a real functions, and the after changing in the z, that is this del z, okay, small change in the z, so that is this one, f z plus del z. Okay, and it is divided by the del z, and you apply the limit, so this is f prime z, like this. Okay, so now if so this I can write like this, limit del z approach to 0 del f by del z. Okay, because del f is equal to this one, that is this quantity, that is f z plus del z minus f of z, like this. Okay, so this is a difference between the original what are the original functions and the after changing the z. So this is the difference between these two quantities. Okay, okay, so I can write like this. Now we know that in the w planes, if we change this z, so in the w plane what we have, del f is equal to what, this is f is equal to what? F is equal to what? U plus iota into v. Okay, so if we change the z, then in the w plane also this function is changed, so that is del f, and this variable, that is del mu, plus second variable is also changed, that is iota into del v, like this. If we change the del z in the z planes, so del z is equal to del x plus iota into del y. Okay, so now here is what del z that approach to z naught, so we can write del x that approach to 0, and del y is also approach to 0. For this del z is approach to z naught, like that. Del z approach to 0. Okay, not z naught. Okay, so these equations I can write limit del x approach to 0 or del y approach to 0. Okay, to del f by del x. And also this del f I can replace with these equations, that is limit del x approach to 0 and del y approach to 0. So for this del f, that is del u plus iota into del v, divided by this del x is what? This is z. Okay, so del z is equal to what? Del x plus iota into del y. Okay, so we know this is in the z planes and this is in the w planes. Okay, this u and v is what? Variables in the w planes, and this x and y, that is a variable in the z planes. Okay, so that we already discussed in the complex functions. Okay, so I am not going to detail discuss this about this u and v and x and y like that. Okay, now similarly what we in the previous example we discussed, if del here is a we are having the three path. Okay, if we consider this del x is equal to 0, then this del y is approach to 0, and another and the second case, that is del y is equal to 0 and this del x is approach to 0, like this. And third case, that is this both variables are simultaneously approach to 0. Okay, so first we consider first two case, that is del x is approach to 0. So if can write if three cases. So first case is what, or the path, I am going to take path first, that is del x is equal to 0 and del y approach to 0, and the second path, that is path second, that is del y is equal to 0 and the del x that approach to 0. Okay. These are the two paths we are considering. If the result of this, if we apply this approach, this path or the limits, if we get the result of this two case is equal, then we can say this limit is exists, that we study in the previous. Okay. So let's check. So for the path first, that is limit this this is f prime z is equal to limit del x is equal to 0, or I am not write this, del y approach to 0. Okay, so already I consider this this x is equal to 0. Okay, so del u plus iota into del v divided by del x plus iota into del y. Okay, so if x is equal to 0, so then what we get, this term is equal to 0. Okay, this quantity that is equal to 0, so can write limit del y approach to 0, del u plus iota into del y plus del iota into del v divided by iota into del y. Okay, so this iota will be cancels and we can write, after applying the limits, we having del u iota into del u by iota into del y, so this is y plus del v by del y. Okay, so I can write this del y and this del u by the del u by the del y is equal to ux. Okay, that we study in the differential equations. So okay, so I can write this uy divided by I plus and this that is uy. Okay, so I can write this minus uy plus u v, step here, this is vy and this is vy. Okay, this is the first part, that is fz primes. This is equation number or a result after applying the first approaching case. Okay, so that is f prime z is equal to here is minus iota into uy plus vy. Okay, if I apply the second case, that is in that case we considering this del y is equal to 0 and this del x that is approaching to 0. Okay, so path second, in the second path f prime z is equal to limit, in that case we considering this del y is equal to 0. Okay, so I am directly write here x dash approaching 0. Okay, I am not right for the, okay, for your understanding. Okay, del y is equal to 0 and what is del u plus iota into del v divided by del x plus iota into del y. Okay, now this, if del y is equal to 0, so this quantity is equal to 0. So what we after substitute or applying the limits, what we get result, if we put this del y is equal to 0, so we get the del u divided by the del x, so that can be write as a ux plus in the second that is iota into del v by del x, so that is iota into v, so not v here, so that is v x. Okay, ux plus iota into vx. So this is the second result, say for the second path or the second directions to approach the 0. Okay, so now if we consider this derivatives of this fz, that is equals, means this result we consider here equals, and if this derivative of these two functions that is equal, then we can, if we compare these two equations, that is 1 and 2, so we get here one relations, and that relation is very important for okay. So if the result of this derivative is equal, then we can write or compare these equations, so we can write this real term, the real, so that is u x is equal to v y, and another that is minus uy is equal to vx. Okay, so this relations is a necessary condition for the CR equations. Okay, it is called the necessary condition, but not a sufficient. Okay, so this equation is called Cauchy Riemann equations. Okay, this is a necessary conditions, that is ux is equal to vy and minus uy is equal to vx. Okay, so this is about the derivative of the complex functions. Okay, and one more topic, that is continuity of the complex functions. So in the continuity of the complex functions, yeah, okay, it is very simple. So I will tell you just definitions for the continuity of the complex functions. It is very simple, so that's why I am not taking in detail. So limit that limit z approach to z naught of f functions, that is equal to f of z. Okay, so this is definition for the continuity of the complex functions. So when z approach to z nodes or the at this point, this f of z is this f of z is exist. Okay, so if we consider in the w plan also, so this w we can write u naught plus iota into v naught. Okay, so this u naught and v naughts, that is exist in the w plane if this at this point of the z naught. Okay, so this is definitions. I am only discuss the definition of this continuity of the functions. Okay, so here is a two case. One is this function is exist, or another this is equal. First one is this one, and second is what, this f of z naught is exist limit. Okay, so this is a like this. This is the first, and the second one is limit, that is at z naught points this f of z must be exist. Okay, so this, if two condition is satisfied, so we can this function is a continuous at the point z naught. Okay, okay, so okay, thank you. Let's stop here. We will discuss in the next topics, that is analytical function, in the next lecture. Okay, thank you.